And you guys know that standard form of a straight line is y equals mx plus c, where m is the gradient, c is the Now that's standard form. What are the other forms that we know? General form. So in general form we would say ax plus by equals a constant. Sometimes it's written like that, other times it's written like this. Okay, you'll see both of those, depending on which textbook we use. But the real mystery is this gradient n. Can you give me a formula for solving the gradient? Yes, bro. Rise of the rock. Gradient. Another one? Bethany?
y2 minus y1 over x2 minus x1.
Thank you, Bethany. Very good. Another one? Yes? N is equal to 10 theta. That's right. Now there is a variation on this one right here. And when we start applying functions, it's the function of b take away the function of a divided by b take a. Alright. Now that is the same as that. That's the y2, that's the y1, that's the x2, that's the x1. Okay. And we say, that's if we're given a function like x squared, y equals x squared. Okay, we plug in the x into the function and come up with the y2. Alright. So what is the equation of this line? Positive 1/2. 1/2 x. Sorry? Plus 6. Do we all agree? The rise is 6 and we go across 3. 6 over 3 is actually 2x plus 6. Okay. Alright, here's the next one. What's the equation of this line? Go on, Bella.
Negative 20 over 9.
Negative 20 over 9x plus 100. Okay. So Bella is saying that from this coordinate we're going to go down 20 and across 9, down 20 across 9, down 20 across 9. That should meet up with 45, 0. Let's check it. The gradient is negative 100 over 45, dividing top and bottom by 5, we're going to get negative 20 over 9. Yes, Bella, I agree with you. Very good. And 10, 20. Alright, yes, Gypsy. We're going to come up with the equation of this line. Might be a bit of work. Yes, Judah.
20 minus 4 over 10 minus 2.
Alright, so you're talking about the gradient formula?
Yeah.
You're solving for the gradient. So you're saying y2 take y1 divided by x2 take x1. Okay, so 20 take away 4. All over 10 take away 2. Which makes 16 over 8, which is 2. do we have a y-intercept? No, we don't. So in terms of our standard formula, we've got that far, but we don't have our y-intercept yet. Okay? So, we're going to use gradient slope form, which goes like this. Technically, it's like this. Okay? But when I teach it, and for your purposes, we're just going to make this into standard form and move the y1 and put it over here. Okay? So when you see it in the textbooks, you'll see the textbook with both y's on the left, but it's not practical. So for when we use it, it's in standard form. So, do we know what m is? We do, it's 2. This is the independent variable x. We don't substitute anything for x. Then we need a coordinate x1, y1. Now which one should we use? 2, 4? We don't want to use 10, 20? Would 10, 20 work? Yes, it will work because the both points exist on the same line. But 2, 4 should be nicer, so let's use 2, 4. And when we expand this, we get 2x minus 4 plus 4, which is 2x. So there is a y-intercept, but the y-intercept is, it is 0. Okay, so this is 2x plus 0. So you don't even bother writing it in. So, if our algebra is, and we'd have to have a scale to make sure we're doing it correctly, so up 2, across 1, up another 2, and across another 1. Okay? And we would check to see if our coordinate lies. So 2, 4, 1, 2, 4. Yes, that one exists, and then I could carry that on a little bit further to make sure it goes to 10, 20. I could do that, and that would work. Yes?
Substitute x and y to the equation.
Which x and which y are we talking about here?
Just the point on the line, the coordinate. Maybe.
Well, we used 2, 4. That's right, Judah. We used 2, 4 to solve the equation. So if I use 2, 4 to check my answer, I could be making the same mistake twice. So the rule of thumb is, if you use this coordinate to solve, use the other coordinate to do your check. Okay. So let's check it. We've got y is equal to 2x. We're going to use the coordinate 10, 20. When we plug in, if we do the left-hand side, which is 20, the right-hand side is going to be 2 times 10, which is equal to 20. Left-hand side equals right-hand side. We did it. Okay. All right, going a little bit faster, I realize. So any questions with that? No? So please put this in your big page of formulas with your highlighters, and girls, you put flowers or whatever you do. Make sure you've got that formula down pat. We'll be using that a lot. Yes?
What is that formula?
This one is called gradient y-intercept form, or slope-intercept form. And it is basically applying, it's solving the equation of a line, given n, and given a coordinate. Yes, Pearl.
What does it question 8 mean when it says which of these lines has a non-zero positive gradient?
Okay. Which of these lines is non-zero? A zero gradient would mean horizontal or flat line. And non-zero positive, positive meaning it has to have a rise in it. Negative has a decline. Okay, let's do these two questions. The question is asking to find the gradient for, it's asking to find the gradient. Okay. Well, what is the gradient for question 3G?
Yeah.
It's 0, isn't it? How do you know? Because, well, first of all, it's completely horizontal. So that's your big clue. If we use the formula, would the formula verify that it is 0? Yes, it would. So if we use the formula y2 take y1 divided by x2 take x1, we would have 3 take away 3 over 4 take away negative 5, which is 0 over 9. 0 divided by anything is 0. Yes?
So is it undefined?
No, we're going to get to undefined in just a second. But this is a 0 gradient. So an airplane flying at 0 gradient just means it's flying horizontal. Okay. So therefore, gradient in this case is 0. Alright. What about this scenario? What's the gradient in this case?
Undefined.
Undefined. That's right. It's vertical. By observation, it's vertical. By definition, undefined. So, when we plug it in our formula, y2 take y1 over x2 take x1, we get 2 take away 9. Now, I'm doing this one subtract this one. I'm probably making it hard for myself. I really should do that one subtract this one. Doesn't matter which way you do it, so make it easier for yourself. Let's go 9 take away 2 divided by 6 take away 6, which makes 7 over 0. SpongeBob says, can't divide by 0. Okay. And why? Because you cannot define it. This is what we call undefined. Okay. In fact, dividing by 0, the whole concept doesn't make sense. If I had 3 hens, and I have 3 friends, how many does each get? They each get 1. But if I have 7 hens, and I share it in 0 directions, how many does each get? The question breaks down. It actually doesn't even make any sense. What do you mean, if you share it in 0 directions, how many does each get? Alright. Let's say an airplane is taking off at 50 degrees. I don't know if that's true or not. I don't know if yeah, anyway. So it's taking off at 50 degrees, and we want to know the gradient at which it is moving. How are we going to solve this one? Gypsy, you had your hand up first?
10 theta.
Yeah, let's use m equals tan theta. And theta in this case is 50 degrees, so tan 50. And 50 is not one of our special angles like the 30, the 45, or the 60, okay, or the 90. So use your calculator for this one, and what's it come out to be?
Negative 0.2719.
Negative 0.2719. Easy. Everyone happy with that?
No.
No. Big no. Big no. Everyone should be complaining right now. What do you mean, Mr. L?
What?
How could it be a negative 0.2719? First of all, 0 means horizontal, right? And so we're just a little bit increment off of horizontal. But the whole thing is negative. So that does not match up with this angle of incline. Well, what happened? Why did we come up with this answer? Yes, Phil? calculator was on the wrong setting. It was probably in radians mode. You need to switch it over to degrees mode.
So I think there's another way.
Okay, we'll get to that in a second.
1.2.
1.2. Excellent. Okay, now, thank you, Aaron, for the answer. Let's have a look at, let's see if we can make sense of this answer. Calculator, Sam, look up here. 1.2. Does that mean anything to us? Can we have some sort of a reference as to whether that's correct, incorrect, within the same ballpark? Does it look right? It looks right. Okay. Why? Why does it look right? Why isn't it 5? Why isn't it 7? Why isn't it 10 or 300? Yes?
If it was 1, it would be going up equally.
Yes, I know what you mean by that. Okay, a gradient of 1 is the same as 1 over 1. True?
Yeah.
Which means that the rise was 1 and the run was 1. Which is a, how many degrees? If the gradient is 1, how many degrees is that? 45 degrees. Okay. So if we're going 50 degrees, we're looking for a value just a little bit larger than a gradient of 1. So this makes sense. Okay. All right, I'm going to